Morning students. Chapter 5 Magnetism and Matter continue. Yes, we have discussed some theory. What is bar magnet? Magnetic field lines, solenoid equivalent to a bar magnet, analogous between electrostatics and magnetism. Yes, we know equations. What is behavior of magnetic dipole in uniform magnetic field? So yes, based on such equations, we will solve some questions. See some simplest questions. Okay. See exercise 5.3. Okay. One bar magnet is aligned at 30 degree in magnetic field B is equal to 0.25 Tesla. Torque acting on it, tau is equal to 4.5 into 10 raised to minus 2 joule. You have to find what is magnetic moment associated with that magnet. Yes, you know this equation. Torque tau is equal to it is md sin theta. Torque tau is equal to it is md sin theta. Yes, make m as subject. So m is equal to it is tau upon b sin theta. You know what is value of tau? B and sin theta. You can easily calculate your answer. Clear about this? Okay. Second question. Exercise 5.4. M is equal to 0.32 joule per Tesla. Magnetic field 0.15 Tesla. Yes, it is uniform magnetic field. First, in stable equilibrium, what is unstable equilibrium? And in such two conditions, yes, you have to find what is potential energy. So yes, we know that what is stable equilibrium when it is uniform magnetic field and magnet is placed or dipole is placed such that it is x and it is n. So yes, magnetic moment m, it is from S to n, m and they are in the same direction. So yes, it is called stable equilibrium condition. In this condition, theta is equal to 0. So u is equal to minus mb cos theta is equal to minus mb cos 0 is equal to, here it is minus mb. Here it is minus mb. Clear about this? Clear about this? Okay, so yes, this point you have to remember. Okay, now in case of unstable equilibrium means when it is magnetic field, magnet is placed such that this n and this n. Magnetic moment, it is from south to north. They both are in opposite direction. So theta is equal to it is 180 degree. Theta is equal to it is 180 degree. What is u? U is equal to minus mb cos theta is equal to minus mb cos 180. Cos 180 means it is minus 1. So it is minus mb minus 1 is equal to, here it is mb. Yes, you know what is value of m, you know what is value of b. Clear about this? Okay, so yes, two simple questions. Next is, if we have a solenoid carrying current having numbers of turns 800, area of cross section is equal to 2.5 into 10 raised to minus 4 meter square, and I is equal to 3 ampere. I is equal to 3 ampere. You have to find what is magnetic moment associated with this solenoid. What is magnetic moment associated with this solenoid? Yes, magnetic moment of solenoid. Magnetic moment of solenoid. Magnetic moment of solenoid. How to find magnetic moment of solenoid? See, M is equal to NIA. Yes, magnetic moment for solenoid. N is equal to NIA. N is given, I is given, and A is also given. You can easily find. Okay. Now next one is exercise 5.6. If the above solenoid is free to rotate in vertical plane having uniform magnetic field B is equal to 0.25 Tesla, you have to find what is torque acting when axis makes angle 30 degree with field. When axis makes angle 30 degree with field. Clear about this? Clear about this? Okay, so yes, you have to find what is magnetic moment. What is magnetic moment? Yes, axis makes angle 30 degree. We know that magnetic moment of solenoid, it is along axis. It is along axis. So yes, your angle between axis means magnetic moment and magnetic field B, it is given 30 degree. You have to find torque. So yes, tau is equal to it is mb sin theta. Tau is equal to it is mb sin theta. What is m from this question? B you are given and theta, yes, the you are given. So yes, you can easily calculate what is tau. Tau is equal to it is mb sin theta. Now next question is exercise 5.7. See what is question. Okay, you are given a short bar magnet having magnetic moment 1.5 joule per Tesla and magnetic field be uniform 0.22 Tesla. Okay, you have to find what is work to rotate and what is torque when magnet is rotated from equilibrium condition to first normal to field and second opposite to field. Initially it is in equilibrium condition. Initially it is in equilibrium condition, means theta 1 is equal to 0. Theta 1 is equal to 0. Yes, we have obtained one equation of work. Work to rotate W is equal to mb cos theta 1 minus cos theta 2. W is equal to mb cos theta 1 minus cos theta 2. Yes or no? Where theta 1 it is in equilibrium condition. So yes, obviously theta 1 is equal to it is 0. Chalo, first case. You have to rotate magnet normal to field. So yes, theta 1 is equal to 0 and theta 2 is equal to it is 90. So what is work? W is equal to it is mb cos 0 minus cos 90. Cos 0 it is yes 1 and cos 90 is 0. So it is equal to it is mb. You are given value of m and you are given value of p. In such condition you have to find torque. So torque is equal to it is mb sin theta 2. Yes, you are given value of m, b and theta 2. You can easily calculate. So for second case, theta 1 is equal to 0 degree from equilibrium condition. Opposite to field means theta 2 is equal to 180 degree. Theta 2 is equal to 180 degree. So yes, W is equal to it is mb cos theta 1. What is cos theta 1? 0. Cos theta 2 it is 180 is equal to cos 0. Yes, we know cos 0. What is cos 0? It is mb. Cos 0 is 1 minus cos 180 minus 1 minus minus plus. So yes, it is 2 mb. It is 2 mb. Clear about this? So yes, you have to remember this equation of work. W is equal to mb cos theta 1 minus cos theta 2. To rotate normal to field, to rotate opposite to field. Yes, torque in this case, tau is equal to it is mb sin theta. It is mb sin theta. Clear? So yes, if you know equations, what is equation of torque, what is equation of potential energy, of magnetic moment, okay, then yes, you can easily calculate these questions. Clear about this? Okay, now we will see next questions. Next question, exercise 5.8. See, you are given a solenoid having total numbers of turns 2000, area of cross section 1.6 into 10 to the minus 4 meter square, I, that is the current 4 ampere. First question is what is magnetic moment of solenoid? Again is the question, magnetic moment of solenoid. Magnetic moment of solenoid. M is equal to, it is NIA. It is given. Simple. Okay. Question B. What is force and torque acting on this solenoid if it is placed in uniform magnetic field? See, students, remember, whenever you are given magnetic dipole in uniform magnetic field, force acting on it is always 0. In uniform magnetic field, F is equal to force, F is equal to 0. Why? Torque, it depends on angle. Yes, it depends on angle. How to find torque? Yes, torque tau is equal to it is mb sin theta. How to find torque? Torque tau is equal to mb sin theta. So yes, you have to remember this point. In uniform magnetic field, force F is equal to 0. Remember chapter 1, electric dipole in uniform electric field, total force on it 0. Clear about this? So yes, it is on this equation. You have to find what is tau. Tau is equal to md sin theta. M is from first question, it is NIA. B it is given here is 7.5 × 10⁻² Tesla, and theta is 30 is given. Clear about this? Okay. Now next question. Exercise 5.12. What is given? See, you are given a short bar magnet. You are given a short bar magnet having magnetic moment m is equal to 0.48 joule per Tesla. At distance 10 centimeter from center, first on axis and second on equator, you have to find what is direction and magnitude of magnetic field. Okay, short bar magnet, m is equal to 0.48 joule per Tesla, at distance 10 centimeter from center, first on axis and then on equator. See here, first of all I will draw magnet. It is magnet. Now it is north pole, it is south pole. Okay, it is its axis, it is its equator. Yes, it is axis and it is equator. We know that magnetic moment, yes, magnetic moment, it is in this direction from south to north. Yes or no? Magnetic moment is in this direction from south to north. Clear about this? So yes, magnetic moment, it is in this direction. Okay. Now, if I draw magnetic field lines on from north pole outside, in south pole it is inside. Another magnetic field lines like this, they form closed loop. From north pole outside, in south pole inside, like this. Clear about this? So yes, it is magnetic field lines. Yes, you know magnetic field lines. Okay. Now, what is given? First of all, on axis. See, first is on axis. R is equal to 10 centimeter, means 0.1 meter. Yes, you are given short bar magnet. We know that for short bar magnet, what is equation? Magnetic field on axis, BA is equal to mu 0 upon 4 pi 2m upon RQ. BA is equal to mu 0 upon 4 pi 2m upon RQ. Clear about this? BA is equal to mu 0 upon 4 pi 2m upon RQ. Any doubt? Okay, so yes, you know what is value of mu 0, 4 pi into 10 raised to minus 7 2, that is 2m. Yes, it is given 0.48, r it is 0.1 meter. You can easily find what is magnitude in Tesla. What about direction? What about direction? See, on axis, if point is here, okay, see carefully, if point is here, we know that characteristics of magnetic field lines. Magnetic field at each and every point is in direction of tangent drawn at that point. Magnetic field at each and every point is in direction of tangent drawn at that point. See, at this point, tangent means it is in this direction. So here it is direction of magnetic field. Similarly, if I am taking point this side, then obviously again magnetic field it is in this direction. Magnetic field it is in this direction. So on axis at any point, see, magnetic field is in this direction, means in direction of magnetic moment. 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 Clear about this? So how to write its vector form? Yes, I can write its vector form as BA is equal to mu 0 upon 4 pi 2 m upon RQ. Direction of magnetic field is in direction of magnetic moment. Clear about this? Okay. Now on axis, then on equator. On equator, again at the same distance, r is equal to 10 centimeter from center. That is 0.1 meter. That is 0.1 meter. What is equation for equator? Yes, you know. BE, magnetic field on equator. BE is equal to, it is mu 0 upon 4 pi. It is m upon r cube. It is m upon r cube. Yes, mu 0, 4 pi into 10 to minus 7, 4 pi m, 0.48, r, 0.1. You can easily calculate. Or, if you do not want to calculate, see, mu 0 upon 4 pi, 2m upon r cube. Mu 0 upon 4 pi, m upon r cube. Distance is same. So yes, this answer will be half of first answer. Clear about this? Rest. Important is direction. Important is direction. How to find its direction? See, on equator, means if it is point on equator. On equator, what is direction of magnetic field? See, here it is. Magnetic field lines are like this, are like this. At this point, that is on equator. If I draw tangent, it is in this direction. It is in this direction. Magnetic field on equator is in this direction. Clear about this? Clear about this? Yes. If I say yes, magnetic field is in this region below magnet, then don't worry. Don't worry. From North Pole outside at this point equator, it is in direction of tangent. So see, magnetic field is in direction of tangent, and from figure it is clear it is in this direction, means in opposite direction of magnetic moment. So here I can write is equal to whatever you have to find just now, in opposite direction of magnetic moment. In opposite direction of magnetic. Clear about this? Okay. So if I want to write its vector formula, how to write its vector formula? BE is equal to, it is mu 0 upon 4 pi m upon r cube. Not only m, here it is minus m. Here it is minus m. Clear about this? And yes, if I want to make what relation between these two, then I can write BE is equal to BE. Like we have obtained in chapter number 1, EA is equal to 2E. Yes or no? Yes. So yes, it is again one simple question, but for direction, you have to draw this figure. You have to draw this figure. Clear about this? Okay. So yes, it is about magnetic field of short bar magnet. Yes, students, watch regular videos, make regular notes, solve your doubts regularly, regular exam, and yes, regular like, share and comment on our videos. Now we will see some extra cases. See, if you have a bar magnet, if you have a bar magnet like this, bar magnet, North Pole, South Pole. Distance between two poles, it is 2L, and pole strength is P. Then yes, we know that magnetic moment, M is equal to, it is P into 2L, means pole strength into distance between two poles. 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 Okay. Now if I cut this magnet from center like this, perpendicular to its length. So yes, I will have two magnets. I will have two magnets like this. Okay? Yes, it is North Pole, it is South Pole. So when we got a magnet like this, yes, remember, if we cut magnet into equal parts, magnetic monopoles are not possible. So if it is North Pole, it becomes South Pole and it becomes North Pole. Pole strength remains same. Pole strength remains same. But what is length? L and L. So what is magnetic moment of individual part? Magnetic moment. Magnetic moment of each part. Of each part. M dash is equal to. What is pole strength P for this magnet? You say M dash is equal to pole strength is P. What is length? It is L. Means it is PL. Means it is PL. Clear about this? Means it is PL. Now magnetic moment of each part M dash is equal to is PL, and PL means it is M by 2. It is M by 2. So yes, magnetic moment becomes half. Magnetic moments becomes half. Means its strength becomes half. Its strength becomes half. That we have discussed in first lecture. Some commonly points regarding magnetism. Okay, when we cut magnet into equal parts. Okay, individual poles are not possible. Individual poles, they are not possible. Okay. These two parts will behave as magnet but having some weaker strength. Clear about this? Okay. Now, one extra question. If I have on a wire having length L, pole strength P, okay, then yes, its magnetic moment is M. Its magnetic moment is M. If this wire is bent in the form of semicircle, if wire is bent in form of semicircle, then what is magnetic moment? Okay, see, initially we have first case a wire, pole strength P, length is L, so magnetic moment M is equal to, it is P into L, because distance between two poles is L, so it is PL. Now this same wire is bent in the form of semicircle like this. So yes, it is one pole, it is another pole. Okay, and now if it is center, then what is distance between them? Yes, magnetic moment. In this case, magnetic moment M dash is equal to P into 2R, because now distance between two poles is 2R. And now how to find what is value of R? See, this semicircular arc is made from this wire. So I can say length of wire is equal to length of semicircle. Yes or no? What is length of wire? L. What is length of semicircle having radius R? It is pi r. So yes, if you make R as subject, then R is equal to, it is L upon pi. So yes, put here value of R, P, 2. What is value of R? R is equal to, it is L upon pi. R is equal to, it is L upon pi. R is equal to, it is L upon pi. Okay, so yes, is equal to, what is PL? PL is equal to, it is M. PL is equal to, it is M. PL is equal to M. So yes, here it is 2M upon pi. Here it is 2M upon pi. Clear about this? So yes, it is magnetic moment of this semicircular arc. Okay, how to solve such questions? You have to remember this equation. Okay, magnetic moment means pole strength into distance between two poles. Clear about this? Okay, again, watch regular videos, make regular notes, send your notes regularly, prepare for exam regularly, solve your doubts regularly, and yes, regularly do like, share and comment our videos.